Pipes are long, hollow cylinders used to transport fluids, liquids and gases, slurries, or sometimes solid materials. They are essential components in nearly every industrial system, providing a safe and efficient way to move materials from one place to another. In industries like oil and gas, water treatment, power generation, chemical processing, and construction, pipes play a crucial role in maintaining smooth operations. Pipes can be made from metal, plastic, cement, or composite materials, depending on the application, pressure, temperature, and the type of fluid being handled. Most common types of pipes used in industry are carbon steel pipes, stainless steel pipes, galvanized steel pipes, alloy steel pipes, ductile iron pipes, copper pipes, PVC, polyvinyl chloride pipes, CPVC, chlorinated polyvinyl chloride pipes, HDPE, high-density polyethylene pipes, concrete pipes. Carbon steel pipes are among the most widely used in industrial applications. Made from an alloy of iron and carbon, they are known for their high strength and ability to handle elevated pressure and temperature conditions. These pipes are commonly used in the oil and gas, petrochemical, and power generation sectors. Although they offer durability and toughness, carbon steel pipes are prone to corrosion and often require protective coatings or linings to extend their service life. Carbon steel pipes used in oil and gas transmission pipelines, petrochemical and refinery piping systems, high-pressure steam and boiler lines, structural and process piping in power plants, firefighting and industrial water lines. Carbon steel pipes' advantages: high strength and durability, suitable for high-pressure and high-temperature applications, cost-effective compared to stainless or alloy steel, easily available and weldable. Disadvantages: prone to corrosion and rust, requires coating, painting, or lining for protection, heavy and difficult to handle, limited resistance to chemical attack. Stainless steel pipes contain chromium and nickel, which make them highly resistant to rust and corrosion. They are preferred in industries that demand cleanliness and hygiene, such as food processing, pharmaceuticals, and chemical manufacturing. Stainless steel pipes are durable, easy to clean, and suitable for both high-temperature and high-pressure applications. However, their main disadvantage is the higher cost compared to other metallic pipes. Stainless steel pipes used in food and beverage processing plants, pharmaceutical and chemical industries, water purification and desalination systems, heat exchangers and condensers, marine and offshore piping systems. Stainless steel pipes' advantages: excellent corrosion and rust resistance, long service life with low maintenance, withstands high temperature and pressure, hygienic and easy to clean, ideal for food and pharmaceutical use. Disadvantages: more expensive than carbon steel, difficult to machine and weld in some GRA. Ductile iron pipes are a form of cast iron that includes small amounts of magnesium to improve flexibility and strength. They are commonly used for water and wastewater transportation systems due to their toughness and long service life. These pipes can withstand heavy loads and are resistant to corrosion, especially when coated. Despite these advantages, ductile iron pipes are heavy and not suitable for very high-temperature applications. Ductile iron pipes in municipal water, supply and distribution networks, sewage and wastewater systems, firefighting mains, stormwater drainage systems, industrial raw water transport. Ductile iron pipes' advantages: strong and durable with excellent impact resistance, long lifespan, 50+ years with coating, corrosion resistant when properly lined or coated, can handle high flow rates. Disadvantages: very heavy and difficult to install, not suitable for very high temperature or pressure, can corrode if coating is damaged, expensive transportation due to weight. Galvanized steel pipes are carbon steel pipes coated with a layer of zinc to protect against corrosion. They were commonly used for water lines and outdoor applications in older systems. The zinc coating provides temporary corrosion resistance, but over time, it can wear off, leading to rust formation inside the pipe. Although durable, galvanized pipes have largely been replaced by more advanced materials due to maintenance issues. Galvanized steel pipes used in outdoor structures and fencing, compressed air lines, low pressure, scaffolding and support frameworks, industrial cooling water systems. Galvanized steel pipes advantages: good mechanical strength. Zinc coating provides temporary corrosion protection. Long lifespan in non-aggressive environments. Suitable for outdoor use and fencing. Disadvantages: zinc coating wears off over time, causing rust. Heavy and difficult to cut or thread. Internal scaling reduces flow over time. Not suitable for modern potable water systems. Alloy steel pipes are made by adding elements such as chromium, molybdenum, and nickel to carbon steel to improve performance under extreme conditions. These pipes are ideal for applications involving high temperatures, pressures, or corrosive environments, such as power plants, refineries, and boilers. Their enhanced mechanical properties make them suitable for critical services, though they require precise maintenance and are more expensive than standard steel pipes. Alloy steel pipes used in high-temperature services such as boilers and heat exchangers, power generation plants and refineries, petrochemical processing and chemical plants, steam pipelines and superheaters, pressure vessels, and high-stress equipment. Alloy steel pipes. Advantages: superior strength and hardness, excellent performance under high temperature and pressure, resistant to wear and chemical attack, longer lifespan in harsh environments. Disadvantages: high material and manufacturing cost, requires skilled welding and handling, susceptible to oxidation without proper treatment. Copper pipes are well known for their corrosion resistance, durability, and excellent heat conductivity. They are widely used in plumbing, air conditioning, and refrigeration systems. Copper's smooth internal surface reduces friction, enhancing fluid flow. In addition, it resists bacterial growth, making it suitable for potable water systems. However, copper pipes are expensive and not ideal for very high-pressure applications. Copper pipes used in residential and commercial plumbing, HVAC, heating, ventilation, and air conditioning systems, refrigeration systems, gas and fuel distribution, hot and cold potable water lines. Copper pipes advantages: excellent corrosion resistance, good heat and electrical conductivity, easy to install, bend and connect, resistant to bacterial growth, suitable for drinking water. Disadvantages: expensive compared to plastic or steel pipes, can be damaged by acidic water, limited pressure capacity, theft risk due to metal value. PVC polyvinyl chloride pipe. PVC pipes are lightweight plastic pipes commonly used in low-pressure applications, such as water distribution, drainage, and irrigation. They are inexpensive, easy to install, and resistant to corrosion and chemical attack. Because they are non-metallic, they do not rust or scale internally. The main limitation of PVC pipes is their inability to handle high temperatures or pressures, which makes them unsuitable for heavy industrial use. PVC polyvinyl chloride pipes used in cold water supply systems, drainage and sewage pipelines, agricultural irrigation systems, electrical conduit and cable protection, vent and waste lines in buildings. PVC polyvinyl chloride pipes. Advantages: lightweight and easy to install, corrosion and chemical resistant, cost-effective and low maintenance, smooth interior reduces friction losses. Disadvantages: not suitable for high temperature, max 60 degrees Celsius, brittle in very cold conditions, low pressure tolerance, can deform under prolonged sunlight exposure, UV sensitive. CPVC, chlorinated polyvinyl chloride. Pipes are similar to PVC, but have added chlorine content, giving them greater heat and chemical resistance. They are suitable for hot and cold water distribution, as well as some chemical handling systems. CPVC pipes are lightweight, easy to join, and resistant to corrosion. However, while they can handle higher temperatures than PVC, they are still not suitable for extremely high pressure or high temperature environments. CPVC, chlorinated polyvinyl chloride, pipes used in hot and cold water plumbing systems, industrial liquid handling, chemicals, acids, alkalis, fire sprinkler systems, water treatment plants, HVAC chilled water lines. CPVC, chlorinated polyvinyl chloride pipes advantages: can handle higher temperatures than PVC, up to 90 degrees Celsius, resistant to many chemicals, lightweight, easy to install, and low maintenance, cost-effective alternative to metal pipes. Disadvantages: still limited temperature and pressure capacity, brittle if exposed to extreme cold, sensitive to UV light if used outdoors without protection. HDPE high-density polyethylene pipes are flexible plastic pipes made from high-density polyethylene material. They are used extensively for gas distribution, water supply, and sewage systems. These pipes are corrosion-resistant, lightweight, and easy to install, with a long service life and excellent impact resistance. Their flexibility allows installation in uneven terrain without joints. However, HDPE pipes have limited temperature tolerance compared to metal pipes. HDPE high-density polyethylene pipes used in gas distribution pipelines, potable water supply systems, wastewater and drainage systems, mining slurry and tailing lines, irrigation and agricultural water supply. HDPE high-density polyethylene pipes advantages: flexible and lightweight, excellent corrosion and chemical resistance, leak-free joints using heat fusion, long service life 50+ years. Disadvantages: limited temperature resistance up to 80 degrees Celsius, requires specialized welding for joints, susceptible to damage from UV rays if unprotected, can deform under heavy loads or heat. Concrete pipes, often reinforced with steel, are primarily used in sewage, stormwater, and drainage systems. They are extremely strong, durable, and capable of supporting heavy loads from above-ground structures. Concrete pipes have a long lifespan and require minimal maintenance once installed. However, they are very heavy, making transportation and installation challenging, and they are unsuitable for applications involving internal pressure. Concrete pipes used in stormwater drainage and culverts, sewage and wastewater systems, irrigation channels and large water conveyance, road and highway drainage systems, underground tunnels, and cable protection ducts. Concrete pipes. Advantages: very strong and durable, long lifespan and low maintenance, resistant to corrosion and chemical attack, handles heavy loads and large diameters. Disadvantages: extremely heavy, difficult to transport and install, prone to cracking if not handled properly, not suitable for pressurized systems, requires sealing to prevent leakage at joints.